Space is cold, right? But what if I told you that there's nothing like the cold you feel on a chilly morning? What we call cold here on Earth simply doesn't exist out there. Today, you'll discover why space has a precise, surprising, and universal temperature, 2.7 Kelvin. On Earth, when we feel cold, the air steals our heat, but space has no air. It's a near-perfect vacuum where conduction and convection don't work. In the cosmic void, objects only lose heat through radiation, slowly emitting energy until they reach equilibrium with their surroundings. And what defines these surroundings? The cosmic microwave background, or CMB, an invisible bath of photons that permeates every corner of the universe. Scientists have measured this background with absurd precision, 2.725 K, no more, no less. But how did the universe get this temperature? To understand, we need to go back in time, exactly 380,000 years after the Big Bang. In that era, the cosmos was a hot, opaque fog with free electrons scattering light as if we were inside a star. The temperature was around 3000 K, similar to the surface of a star today. Suddenly, in what we call the era of recombination, protons captured electrons, forming neutral atoms. The universe became transparent. That first flash of light escaped and began its journey. As space expanded, the waves of this light stretched from visible to infrared until they became microwaves. And guess what? 13.8 billion years later, those same photons are still reaching us. It's the afterglow of creation, cooled by the expansion of the universe itself. You might imagine this background is uniform, like a smooth canvas, but it's not. It has microscopic temperature variations, differences of just a few microkelvin. These tiny ripples are like the DNA of the cosmos. Slightly denser spots attracted dark matter and gas, seeding every galaxy that exists today. By measuring these patterns, scientists discovered something unsettling. All the matter we know, stars, planets, you and I, is only 5% of the universe. The rest is made of something mysterious, dark matter and dark energy. In other words, a simple cosmic thermometer reveals not only the temperature of space, but also the secret ingredients of the universe. And if you're curious to understand what dark matter is, watch the video linked in the card above. You're sure to enjoy the content. Back to our discussion on the temperature of outer space. Could anything be even colder than this thermal floor of 2.7 K? Incredibly, yes. The Boomerang Nebula, for example, reaches just 1 K, the coldest known natural place. And in the lab, we've created even more extreme temperatures. Space detectors like XRISM operate at an incredible 0.05 K to register the faintest signals from the cosmos. But here's the point. These cases are exceptions. The true universal thermometer remains the cosmic microwave background. It's a cold that isn't empty, but rather the persistent echo of the Big Bang. And why does this matter to us? Because every satellite, every probe, every astronaut needs to survive in this constant 2.7 K bath. It's the backdrop against which all space exploration takes place. But beyond the engineering, there's also poetry. This faint glow is the oldest photograph of the universe, a record of its cosmic infancy. From now on, whenever someone asks if space is hot or cold, you can answer. It's exactly 2.7 Kelvin, the phantom heat of the Big Bang, still echoing through the cosmos. And if you were as fascinated as I was by this dive into the origins of the universe, leave a like, subscribe to the channel, and continue exploring the mysteries of the cosmos with us. Because, believe me, the next mystery might be even more mind-blowing.